Okay, so quality framework. So we're going to do in this module is talk about quality and what it means in TPI and the benefits you get by managing quality. Some of the major aspects are mentioned on this slide about finding mistakes early in the process. We'll talk about more in detail, and then why you need to start managing mistakes at a personal level, individual level. And then we'll cover a number of techniques used for finding and fixing mistakes or finding mistakes. And that'll be a major portion or a good portion of this module. So what's quality in the first place? Super common term, means 1,000 things. In TPI, at the highest level, the simplest, shortest breath, it's making the customer happy. If you got a happy customer, you have a high quality product. Now, customers tend to focus on the now and their experience. So if you deliver a product, and we talk about the quality of the product, then the user looks at the functionality. Does it do what it's supposed to do and not do what it's not supposed to do? If it checks all those boxes, you have a happy customer. Now, if the customer is using the product over time, now you're going to start to see the customer focusing on some of the what I call illities or properties, like the maintainability. When the customer asks you to change or modify it, how hard or easy does it, or how much does it cost him for you to touch that? Another part is reliability. As time goes by, is the tool down sometimes when they need it? And there now you have a less of a grade. Your A becomes a B in their eyes if the reliability is not high enough for them. If the availability of the tool isn't high enough for them. Usability. Over time, they're going to use more and more of the features, and they may find that it might be difficult to use. And then their usability, the consideration of usability of the product is lower, and that causes your product to have lower quality in their eyes. So those illities all come to light over time. But the user focuses on the functionality and then on a lesser degree on these illities. Now, rarely does a user care about how many mistakes you make in the production of that product. And that's one of the things that we're going to focus on is the mistakes found during the development of the product. Another word for that you're going to see is rework. So in the creation of the product, if the team's working on it and has to go back and throw away some of the work and rework it some more, that's where we're going to focus on quality in TPI, because the user has natural pressure on the team to focus on making sure the functionality and the illities are being met. Okay, so as far as quality in TPI about collecting information about them, there's two major aspects of quality. One is the quality of the product. Again, a product, or the quality of the service. It also applies that. I'll just focus on product for now, but all this applies to services also. So you have the quality of the product, and then there's also a quality of the process. So on the quality of the product, you can measure things like how often you make mistakes. And again, when you're done, you look over your shoulder and say, it took us X hours of coding. And during that time, now that we're all done, we found the mistakes in our coding. How many mistakes an hour did we make while we were coding? Likewise, you can also look at the testing phase, for example, or the review phases, and you can look at how much time you spent in there and how many mistakes did you find. And so this again is pulling mistakes out of the product during the development. And when you deliver the product, then the user is going to report how many mistakes, problems they found by telling you, hey, this isn't working right. Hey, you need to fix this. And there you can also see how many mistakes, the second bullet is really talking about during the development, how many mistakes did you find in the product, or during the standing up and preparing for the service, for the preparation and delivery of the service, how many mistakes did you find? And so this is important for understanding. When you compare it to your plan, you have planned mistakes you're going to find and actual mistakes you found. That's going to tell you whether or not you found enough for you to deliver the product or to deliver the service. Now, on the second part, the quality of the process, you can look, like we saw some comments made earlier in the chat, about how quickly you're doing a review. There's a sweet spot. If you do a review of your product, like requirements per hour or software lines of code per hour, if you review them too quickly, you're going to be working at such a high level, you're probably going to be missing a lot of the mistakes you could have found. Likewise, if you're reviewing too slowly, then you're probably putting the 20th coat of wax on the car, and maybe you don't have to do that many coats of wax and still get the same benefit. That's one kind of insight you can get by looking at these metrics for the process. Another aspect of it is by comparing times of two different phases of your process, like the time you spent in review versus the time you spent in test. Same kind of thing as before. There's a sweet spot. There's a good ratio of review time versus test time. And if that ratio gets out of bounds one way or the other, then it shows an opportunity for improvement. So what is a mistake? All right, so we talked about what quality means, that's rework. So what's a mistake? A mistake is when you have to change something after you thought you were done creating it. What does that mean in a more specific example? Okay, so um, let's say you wrote a requirement. You drafted it, you put it out there in the requirements, and then you have it go through an inspection. Someone goes, Brad, this is all wrong. This is all talked about in the other section. You go, oh shoot, I have to go change it. The fact that you're changing that requirement you drafted is an indication that you made a mistake. And so that's what we're talking about, is having to rewrite something that you did earlier that you thought you were done with. In a perfect world, you write the requirement, you look at it and say, oh, that looks great. Your friends, your team would look at it, they say, Brad, you are incredible writing requirements. And then the people would take it and develop product after that requirement. They say, I wish you wrote all my requirements, Brad. But that's not what happens. We make mistakes. We're human. Okay, so now any changes you make to a product after, as a result of someone, you looking at it, your team looking at it, or you testing it, like in software, you test it and it fails the test, that's going to be a mistake because you have to go back and fix the mistake you found, fix the mistake the inspectors found, or fix the mistake that caused the test to fail. Those are examples of mistakes. Now, mistakes end up with the product not doing what it's supposed to do, hard to use, hard to run, hard to install, cause incorrect installation, documentation isn't very helpful, and then it's hard to do the utilities, maintaining it, reliability, those kinds of issues. All of those can be the result of mistakes. And anything that has an artifact can have a mistake in it. So mistakes can cost a lot or a little. So here's two examples of ways a mistake is found and fixed. So you have someone, let's say that they are writing code, and they write their code, and they've done writing some code, add a button to a display, and they then look it over and see if they have made a mistake that they've made in the past when they've done this before. Oh, they find it, and they took some time to do that personal review, and it takes them less than an hour to fix it, and we're all done. That's one person's time was involved. All right, now let's look at the same problem found in a different place. A customer is using this team's product, let's say in an airplane, and they're flying across the range, and they go and hit that button that was added, and it doesn't bring up the new display like it's supposed to. And they land the airplane, they write up the problem, and they submit it to the organization. Organization then turns around and does all the other steps where they look at the problem, give it to a different team, and try to figure out what kind of problem is it. It goes through and bounces around like a ball in a pachinko machine until it finally gets to someone that they think they can go figure it out. They go dive into in this case, the code maybe, and they find that, yes, there it is. And we're not even sure if it's the original author that finds it. They try to fix it. They fix it, and then they have to rebuild the software, put it back, and get it tested to the point where the pilot ends up in the aircraft again, flying over the range, hits the button, and the right display comes up. Now, from the moment the pilot saw the problem until the pilot sees the problem is gone, all the effort involved in those bullets there are all part of the rework. So how much do you think that second scenario costs from the first? Click once, Jeff. So here you got the dollars in both ends, but You really have a lot of costs in the second scenario. Range time is really expensive. So in avionics, this is a really bad problem. So you want to find all the problems from the first situation. And this is we're getting into one of the reasons why you want to find mistakes early in a process. So here's an example on a linear scale of the calendar time. And so see that first row with all the green and the red on the right side? That's a team where they do all their development and they produce their product. They write the requirements, write the software, uh, and then they test it at the end to see if it works. And they find, oh, it's not working, and they spend a bunch of time trying to fix it. In the field, in teams that don't use TSP and TPI, that could be half of the development effort. Now, look at the bottom part where you have a team that's doing some work. They have their work reviewed and inspected at different stages, and they find a mistake earlier in the project process, and they fix that, and they go on. And when they get to testing at the end of the system, they don't find as many problems, and so they end up with less red, less rework because they fixed a problem early on, less cost than if it cost them at the end. Now, instead of project, change that to what we call in dashboard a component, a rock, one of the pieces being done in a cycle. An individual can have the same experience where they do their development and they don't try to test until the very end of that. I put the button on display and they find all kinds of problems, they have to fix them. If that individual instead, when they're doing the development, they had their design reviewed and inspected and their code reviewed and inspected, and they get to testing, they're not going to have many problems with that one button being added to the display. So they experience the same benefits at the micro level down at a single rock of all the rocks being dealt with in a cycle. All that leads to the fact that you are going to produce a better product because less mistakes will leave the team and get to the user's hands, and better service, the same thing. And because you're controlling that massive unknown of how long testing is going to be at the end, you've reduced the variability at the end. You're going to have a better ability to be able to say, yes, I can deliver this next cycle in 6 months plus or minus a week, not plus or minus three months. So one of the big things in TPI, and again, this carries on, like Jeff said, we're standing upon the shoulders of giants. One of the things in TPI is we're trying to minimize the rework it takes to fix a mistake. We know that people doing the work are human, they're going to make mistakes. The trick is to minimize the rework. So the principle behind minimizing the rework is to find the mistake right after you've made it. Now, I know we don't know when we make mistakes, but as soon as you think you're done writing the requirements, you can look for a mistake. As soon as you're done writing the software, you can look at the code, see if it's a mistake. As soon as you're done with the design, you can look at the design, see if you made a mistake. So there's opportunities right away to look to see if you made mistakes. And then the second part is the mistake should be fixed by whoever made the mistake because they know the context, they know the assumptions they were doing when they made the mistake. And so there's your absolute minimal rework. You find it as soon as you made it and to have the person who made it fix it. And that, if you're doing that, then you're going to have a process that looks for mistakes early. And whenever a mistake is made, it captures data on that mistake, how long it took to fix, what kind of mistake was it, and you're going to use that data to make your next time you look for mistakes better because you're going to look for that new mistake. And that's the way improving your process. And so that results in you finding more mistakes during development and delivering less mistakes to your customer. So this has got some animation on it. So don't do any clicks, Jeff, until I say so. So we're going to talk about this feedback mechanism, how this works in the terms of fencing. Yes, that's a man in a white suit with a white hat with a pointy thing on his hands. You guys have seen the Olympics. There's fencers. Well, I took a couple of classes on fencing, and I taught some to my Boy Scouts. So go ahead and click once. We're going to look at the life and the evolution of this fencer, me, from the point of view of whether I'm conscious or unconscious of my problems or my abilities, and whether I am competent or incompetent in doing this ability. So click once. Brad has bad luck. That's what he thinks. He fences and he loses his most of his matches. And a match is 5 touches. You touch the other person 5 times before they get you get touched 5 times. So he loses a lot of matches and he thinks this is bad luck. But his real problem is he's not aware of his mistakes. Now I'm going to look at one aspect of fencing. This is going to be his stance. Just like in everything, there's different facets of doing something. We're going to talk about his stance. So someone tells him, Brad, instead of whining, why don't you start logging and tracking what happens to you when you fence? Click once. And so he starts logging whenever he gets touched. After a match is over, he writes down where he got touched, how soon in the match he got touched, writing down the touches against him. And so what happens? Click once. He discovers he's not God's gift to fencing. He is making mistakes. He finds out that 3/4 of his touches against him are on his front shin, which he has too far forward, so his stance is wrong. And now he is conscious of his incompetence in his bad form to stop him from being touched. But he can then act on that. Click once. So he starts to go, well, what if I shift my weight and move my front shin back? Then people have to reach farther to touch it, and I'll have them closer to me and I can touch them first. So he makes a change to address that 75% of his touches against him are on his front shin. Click once. And he finds that his adjustment in his stance is better. So every time he gets into a stance before he gets into a fencing match, he checks out his stance and goes, oh, my shin is too far forward. And he moves it back before he engages the opponent. So he has to consciously be aware of the change in his process. And what does he find out? He's not getting as many touches on his front shin. He's getting more touches on them. He's starting to win more matches. Click again. At some point, he looks at his form, and again, just focusing on his form, he looks at his form before he engages the opponent. He finds his shin is back often, more often than not, until finally his shin is always back where it should be in the new stance. And so he has institutionalized a better form. And so he, then click once, is now God's gift to fencing. And people go, Brad, you're in your 4th Olympics on the fencing team. How did you do this? How did you get so good? And he just says, I fence. And so he has focused on his worst problems because he continues to log mistakes the entire time. And he goes through this process in every aspect of fencing and until he has found he's doing it right. And he's not thinking about it. He's looking for the next part of his process that is causing problems. And then, click once, Jeff, you can take this whole context and take the fencer out of the picture, click again, and now put a developer of requirements or a developer of software in there. And so if you're writing bad requirements or writing bad code, you may be unconscious about how bad you are at writing software or writing requirements until you start logging your mistakes. And then you will become conscious of the fact that you are bad at writing requirements and bad at writing software. And then you use that data from logging your mistakes to capture and change your process so that you are writing now consciously writing better requirements and better software because you review your requirements and software looking for the same mistakes you've made in the past. You will find over time that you are not making those mistakes as often and you are writing better requirements and better code the first time. So I don't care what the picture is in the middle, this works for whatever you do multiple times. All right, so your process. The steps in your process of the workflow, they have these phases we talked about earlier, the steps, and steps tend to be one or another. Either there's a step where you make mistakes, like you're creating a product or creating an artifact, or steps where you are trying to remove mistakes, identify mistakes. And those are like the green boxes, the personal review, the team inspection, the test. A good process has the creations not last, but somewhere in the process with as many mistake fixing phases following it before it leaves the author's work. So we're going to talk about some of these techniques for finding mistakes. ID and TPI is when you find a mistake, you fix it. I know some organizations say, well, I found a mistake, I'm going to write it up for someone else to fix. We're talking about during development here, rework. So when you're doing these things, when you are aware of a mistake, you fix it during development. So there's three of them I just talked about in the previous slide: personal reviews, peer reviews or inspections, and testing. Now, when you're outside of TPI and you're doing work in the more typical field out there, the more common field, I should say, um, projects tend to wait until the end when they do their testing to try to see if they can then find and fix the mistakes. Bad dog. When that happens, a lot of mistakes are never found by the development team and the customers find it instead. So let's talk about each of those three techniques. Personal reviews are data driven. What are you looking for? You're looking for the mistakes you've made. Not, let me just look to see if I'm following all the standards. No, you focus on looking for the mistakes you've made in the past, when you've done this job in the past. And that your goal is to try to find as many of those mistakes as possible that you have made again, because you're a creature of habit, before you go on to the next phase, whatever that is. And that, the way a person review executes is you look at your product after you think you're done with it. I drafted my code, I drafted my requirements. Wait, I'm going to look it over to see if I've made my mistakes and fix them if I find them. Now, another way is personal or peer reviews or inspections. The goal here is also to find mistakes before it moves on to the next step of the workflow or the process. Only this time, instead of you looking, the author looking at it, it's this team members are looking at it. And so it's done in 1,000 different ways at different levels of formality. Fagan had very disciplined ones where they all sat down and went over a paper copy of the document. Most of our teams, they do it remotely where it's posted on a shared drive like I talked about before, and the individual inspectors look at it. They document their concerns or questions or what they think are mistakes, post them somewhere in the shared drive. The author is then told the inspector is done. Author goes out, looks at it, and resolves the mistake either through clarification if it's misunderstanding or fixing the product if it's an actual mistake. So that's a no meeting room, no logistics of holding a meeting. But either way, you're focused on making the product better. Let's see here. Did I have, there's a, and we don't talk about workflows in this one. I'm sorry, walkthroughs. Walkthroughs are very high level. This is useful for any artifact that can be shared. So if you can post it, you can share it, then your inspectors can be identified and given to it to beat it up. Testing. So services can be tested with a dry run, for example. But you have a product that can be tested. That means it has a behavior. So this is really easy to talk about when we talk about requirements and code and design. So this is really a software-centric discussion, especially when you look at the bottom part there. Those are software testing terms. So this is really important in software world, but it can be applicable in other worlds. So in testing, what you're doing is exercising your product. You're putting it through the paces, seeing if it behaves properly. And if it doesn't, you fix any mistakes until it behaves properly. And there's all different levels of testing. There's testing individual pieces of software, or there's testing where the whole product is, where the whole system of products are, when the customer is about to take the whole system from the development team, all the way up until the pilot's in the aircraft flying on the range. Why is testing a bad place to find mistakes? Because it's really hard to do good testing, thorough testing. There's the middle section there where it says there's so many different permutations. There's all these different factors that are running. You just don't have time or resources to make enough testing to test every permutation, every combination. And so what happens? The testers, whether it's developers or the test team, tend to focus on the most common combinations of factors that are most likely to occur when the customer is using the product, like clearing a path through a minefield. You don't clear the entire minefield, you just clear a path through the minefield. Well, Murphy makes sure that users walk off the path and they stumble across areas that have never been cleared and they find the mistakes. So the bottom part of this slide, now we're talking about in TPI, some of the principles we lay out involving testing is don't even think you can put quality into a product when you test it. It's not an option. No one has testing good enough or the resources to do testing good enough to make a bad product good. You will only find a fraction of the mistakes that are there in testing, like less than half. So, second bullet that's blue there, if you want to get a quality product out of testing, you better do the work before testing because it has to be a good product coming into testing to make it good enough for the user when it comes out of testing. You can only bump it up a little. You're not going to bump it up a lot. So if it's ugly, it's going to be ugly coming out of testing. If it's good going to testing, it'll be good coming out of testing. Testing should be used for validating and verifying. Does it work right? Yes, it does. Is the quality there? Yes, it is. That's what you should be doing in testing, not debugging. You will find mistakes. Great, fix them. But the majority should be found before testing. Okay, so reviews versus testing. We see in the field, not on paper, thinking theoretically it might work. We see in the field that reviewers and inspectors get 70% of the mistakes that are there found. I see teams at 80%. So this is common. This happens. This is not, well, in 20 years you can get this. We see this almost right away, especially when the reviews are using are being done. Personal reviews are being done properly. It gets way up there. So reviews and personal reviews and peer reviews can find lots of the mistakes. We'll talk about the percent in a second here with the illustration, but when you get it testing again, it finds less than half. So one of the nice things about that picture I showed you a couple slides ago where it was a personal review, peer review, and testing, you can compound these phases where you're trying to find and fix mistakes. And they compound as far as how many defects or mistakes are left. You can find some of them and then find some more and then find some more. And each one finds a percentage. And that's what this percentage is. We call it a yield. And each phase can have a yield. And the phase yields for reviews can be much higher than the phase yield for tests. And so you want to take advantage of that and do personal reviews and peer reviews for all the artifacts you can before you get to testing. And so once again, that second bullet down there is that the cleaner the product is when it enters a phase, the cleaner it will be when it exits. And so in testing, you need to be really clean because you can't get much out of it. All right, here's an illustration of it. So you have someone who, when they created their product, the state set of requirements, no, say software because we're going to talk about testing. They made 100 mistakes. So there's 100 mistakes in there, and then they look over that code that they wrote, and they're going to get a 70% yield. The inspector is going to get a 70% yield, and the test is going to get a 40% yield. And here's what those mean. In the personal review, the person looks over their code and they find, wow, I found 70 mistakes. I must have found them all. I thought I made it right, but 70 mistakes, there can't be any left, when in fact there are 30 mistakes left. Now, he turns it over to the inspector and says, you guys aren't going to find anything. They look and they go, Brad, here's some mistakes you got to fix. Brad's crestfallen, but he goes, thanks, guys. Awesome. I thought I really had them all, but with these 21 you found, it's got to be perfect. Little does he know there's 9 left because he doesn't know they made those mistakes. The inspection team did the best job they could. And then he goes into testing thinking he's going to just hit the button, everything's going to work. No, he finds 4 mistakes. He goes, well, I'm glad I did testing. And so now he sees that he and his team have found 95 mistakes. And he doesn't know it, but when he hands it over to the customer, they're going to turn around. If they are using it thorough enough, they may find the other mistakes with Murphy's help. What if he didn't do the personal review? Let's just pull that out and he thinks, I'm God's gift to coding. I don't need to do personal review. So we'll skip that, and the team will still do as good, and testing will still do as good, but he still makes 100 mistakes. He's not God's gift to coding. Well, the team goes, dude, last time we only found 24. Now we found 70. And Brad goes, hey guys, you saved my bacon, thanks. Now you know it's perfect. You found 3 times mistakes you found before. So it's gotta be good. Well, the test gets the 30 that weren't found by the inspectors. And so test being as ugly as it is, only finds 12 of the 30, and that leaves 18. Skipping that personal review caused more than triple the mistakes to go to the customer. Super ugly result for the customer. Instead of 5 mistakes, he's getting 18. This is an example of wanting to have as many phases in your process where you're pulling mistakes, trying to find mistakes and pull them out before you deliver the product. So last slide for this topic on the framework for quality is the idea behind quality is to manage them. Once you've got some history on the rate at which you make mistakes and the fixed mistakes, you can start to plan on making mistakes the same rates and finding mistakes at the same rates. And so when you're in the middle of your cycle, the team could say, ooh, we're off the mark. All our inspections aren't finding enough mistakes. We got to change something or we're going to deliver a buggy product. And so they can see the trains come out the rails before it really does. Managing the mistakes, having a plan and your mistake generation and identification, and then managing to that plan is going to help you have a really good product at the end. Is going to be having you add phases to your process earlier to find the mistakes. You're going to do personal reviews on everything, and your testing is going to be looked at as a verification validation phase, not a debugging phase.